Dear friends, students in computer science, welcome back to Computer Guru VKJan's computer classes. In this module, we are going to learn data center design in a very short time. Dear friends, I know in such a short time you cannot learn the ins and outs of data center design, but through this picture, I am letting you know uh, what is a data center. Say, data center has got data center servers. These are the servers, and electric supply may be a floor above or by side by floor. Here you have a main switch panel. This is power supply transformer and power supply unit, and after that we are going to medium voltage panel. From this panel, if this transformer fails, you get electric supply through generator, and these are generator transfer switch. That means when the transformer fails, the load is given to generators. Then you can have UPS also. Uh, the generators are generally designed for half the total load. Remaining is not supplied. And when generator also are over, the load is on UPS transfer. UPS saves the data. Then for UPS, if you are having UPS, you have to have a battery rack there. So batteries supply the UPS. UPS holds the data, and before adjusting, it saves the data in previous state, and when it is transferring its load to generator, the generator it, automatic transfer switch are there. They may go automatically, or you have to manually put them on. And this generator is normally supplied through transformer. So generator half the load may be emergency load, and that is fed through generator for hours together. Then I come to data center. In data center, you have the servers, and you have a air conditioning system supplying, keeping it the atmosphere cool. And normally the temperature should be below 21 degrees Celsius. So the UPS for data center, the electric the cooling is very much necessary. So these are the power distribution module here, and that's all. Dear friends, data center design is the process of planning the physical infrastructure, power, cooling, power and cooling, air conditioning, networking, uh, security and operational architecture needed to host IT systems reliably efficiently and securely. The core components of a data center design, one is site selection, in which due consideration is given to power availability and utility redundancy. Fiber network connectivity should be available. Climate and cooling efficiency. Uh, the natural disaster risk to be managed. Land and construction cost is involved. Then you have to see the regulatory environment. You have to seek the permission from local authorities having jurisdiction. Typical locations are urban edge are for low latency, rural cold regions for energy efficiency, and near renewable energy sources should be available. Dear friends, the design process involves first requirement gathering by the users, then capacity planning, then you have to design the electrical system, and then you have to design mechanical cooling design. You have to see network availability and its architecture. The center has to be secured in respect of data as well as physical security, redundancy and modeling. You have to see how much extra things are needed. CFD airflow simulation. This is done for air conditioning. This is fluid dynamic subject. Then construction and commissioning. The construction time and commissioning time also takes time because you have to seek permission from local authority. Monitoring and operations. This goes on. Dear friends, I am letting you understand the size of power required. You can calculate manually. LED bulbs are normally 9 to 15 watt. Ceiling fans require 60 to 80 watt. Laptop requires 40 to 70 watt. Desktop PC normally requires 150 to 400 watt. You have to have air conditioner if data center is in a small room, and the air conditioner may take 1000 to 2500 watt. Each AI server rack requires 10,000 plus watt. That means if you are talking in kilowatt, 10 kilowatt. Gaming desktop may require 300 to 800. Workstation normally requires 400 to 600 watt. All-in-one computer. This is your monitor plus CPU all in one. This requires 65 to 150 watt, low, very low voltage requirement. Cloud data center 10 to 200 megawatt. They consume lot of electricity because they have to serve a million of people. Supercomputer maybe 5 to 100 megawatt. The other thing is facility and its share in total air conditioning needs 30 to 50% of the power requirement. Computer and monitors may require 15 to 30%. Lighting is limited to 10 to 20% thanks to LED. Cafeterias and support service uh, also require very less area, 5 to 15%, and local server rooms require 5 to 20%. Friends, for example, let us take a small enterprise data center. Uh, IT load about 100 kilowatt, racks 20 kilowatt, redundancy and plus one. If you require 5, you need one extra. UPS 150 kVA, cooling through air conditioning system, network, leaf and spine, tier, tier 3, tier 3. Power supply distribution arrangement. Different type of power supply system are provided depending on their need. The power supply is segregated at TPN DB level itself. Certain loads are fed through UPS as there the data may be lost if electricity goes. UPS may be designed for at most 30 minutes and then the power is uh, supplied through generating sets. That means generating sets takes over the load of UPS as well, which finally transform the load whenever normal electric supply through transformer is available. The cost of power system increases in reverse order. That means UPS are costliest, then generator, then transformer, 1 kVA basis. UPS are deployed in operation theaters and data centers and similar life-saving uh, equipment. Friends, thanks for peacefully and meaningfully watching this presentation. Thanks once again from Engineer Guru Engineer Vicky Jain. I'll tell you one very funny item. Say there will be very few persons which have done and actually designed the data centers and not only designed but constructed and after constructed maintained them. I served CPWD for 35 years continuously and I have to take up all this type of responsibility. Okay, thank you.